Hey guys, welcome back to another video on the channel. This is a follow-up video to the previous one where we did connected particles with equal angles. Now we're doing one where we have two different angles here, okay? So the reason why we're doing this one here is tension 1 isn't necessarily equal to tension 2. If it was, it would be a complete miracle and probably would break the laws of geometry. But anyway, let's get on with it pretty much. So what we're going to do is find out the tension in this string here and this string here that's holding a particle of 8 kilos up pretty much, okay? Now, you can see here from the diagram that the particle is in equilibrium, so it's not moving up or down or slaying left or right. The reason for this is because the components of the tension vector here, of each of them, are counteracting each other, okay? So what that means is, the sum of these two components here is cancelling out the weight pretty much, okay? And the component here and the component here are cancelling each other out pretty much, okay? So pretty much it's not slaying left or right. So pretty much this component here, this pink bit must be equal to this pink bit here, okay? So what we can do is actually work out what those are respectively, okay? So the way we can do that is work out this angle in here. So this has to be 90 degrees. So 30 minus 90 would be 60 degrees in here, okay? So 60 degrees, and 40 minus 90 would be 50 degrees in here, okay? So this first triangle we get here is set up exactly like so. So this is tension 1 and this is 60 degrees. So this side here is your opposite side. So this is going to be T1 sine of 60 degrees. And then we can move this guy here. This is going to be the adjacent. So this will be T1 cos of 60 degrees. Okay. And you can see this is the corresponding green component here. And this is the corresponding pink component here. Same thing can be done over here, except we have this triangle here. So we have, this is T2, this is 50 degrees, this is, right angle. This is your opposite, so this is going to be T2 sine of 50 degrees. Now remember, this is all in kg weight, so we don't have to worry about force due to gravity because it's actually built into the actual units itself. And this is going to be T2 cos of 50 degrees, and you can see this is the pink component and this is the following green component, okay? So the pink component here is actually the same force that is actually up here in the pretty much workings of whatever the ceiling is pretty much, okay? So those forces are making sure it doesn't slay left or right. So your first equation is pretty much is that this is exactly equal to this. So what we get is T1 sine of 60 degrees is equal to T2 sine of 50 degrees, okay? So this is equal because the particle isn't slaying left or right. Now, the next equation is a bit trickier to think about because this component is holding the block up, but so is this one. So the sum of these two is equal to the counteractive force, which is your force due to gravity. So that means T1 cos of 60 degrees plus T2 cos of 50 degrees is equal to 8. And then we have two equations here, okay? So now it's just simultaneous equations. So we have this first equation and then this following equation here, okay? Now you can do it multiple of ways to sub them into one another. So all I'm going to do for the first one is pretty much, all right, I'm going to make one of them the subject. So if I rearrange T1, if I divide both sides by sine 60, I get T1 is equal to T2 sine of 50 degrees divided by sine of 60 degrees. Now I'm leaving it in terms of the signs because some of these numbers aren't going to be very nice, like sine of 50. And then all I'm going to do is substitute this guy into where T1 is seen there, okay? So if we do that, what we're going to get is T2 sine of 50 degrees over sine of 60 degrees cos of 60 degrees plus T2 cos of 50 degrees equals 8. Now you can see here in this new equation here, we can factor out T2, so we get T2, and we can factor out all these terms here. You get sine of 50 degrees, and then sine of 60 degrees, times by cos 60 degrees, plus cos of 50 degrees, is equal to 8, okay? So what we can actually do here is, if we wanted to, is we could divide the entire equation by this, but at the moment that's pretty messy, so what we can do is use a calculator to work out exactly what it is. Now I'm probably going to round to a couple decimal places, so it's probably going to be the exact number because sine of 50 will be rounded, but sine of 60 and cos of 60 will give you exact values, I know that for a fact. Cos of 50. So with rounding, this green bit here is about 1085, I'll leave it like that for now, times by T2 equals 8, okay? So then T2 is going to be 8 divided by whatever this green number is. Now I'm going to leave it in my calculator to get the most exact value possible. So answer, so this green bit here, I'm just going to emphasize it there, gives you 7.372. So if your T2 is equal to 7.37, this will be in kgWt, so weight. You can then use this guy here to then work out the corresponding T1 force, okay? Because we already have an equation for it up here. So if we just move this guy all the way down, we can just substitute it in. So we can just go, all right, T1 is equal to 7.37 sine of 50 degrees divided by sine of 60 degrees. You can chuck that in the calculator, so I'm going to chuck in the exact number, so I'll give you the exact one to a couple decimal places. This is about T1 is about 6.5216 kg weight, okay? And that's how you do this connected particles one. Pretty easy. You can do it also with the triangle rule, but I like to think of it in terms of the components because it helps the mechanics a bit more and it helps your understanding. Okay? Righto, I'll see you in the next one.